Saxon Algebra 1. Excuse me, I'm adjusting my studio. Lesson 72. It's another two-parter, you guys. The first part is kind of like the first part of the last lesson. Factors that are sums. That sounds weird. What does that even mean? Once I write it down, you'll see the drama. Write it down with me. We're supposed to factor this. What we can see is that the gods of havoc are running amok in our trinomials again. Here is a perfectly respectable trinomial, right? X squared minus x minus 6. But look at these a plus b monsters that have invaded. We got to get them out. And it's easy enough to do. We just factor them. The way we factored numbers and letters and signs last time, we can factor what's called a sum this time. So we're going to pull that out, and then we'll have x squared minus x minus 6. The fact that this is on the back end of the sum and this is on the front end, it doesn't change anything. All right, so this time we're pulling out binomials rather than just letters, numbers, and signs. All right, but it's the very same thing. Then we factor this. This just chills at the front. We ignore it. Then we set up our art project, x. Okay, we're looking for two numbers that multiply to minus 6, add to minus 1. Okay, I'm pretty sure it's not the 1 and the 6, so I'm going to try, let's see, it could be positive 2, negative 3, or it could be negative 2, positive 3. I'm pretty sure it's one of those. I'm not even going to write down the 1 and the 6. I have to add to minus 1. That's invisible in there. And so that would be this one, right? So it's x plus 2, x minus 3. That's our final answer. Okay? Yes. Two more of those. Factor. I mean, again, I'm not exactly sure why John feels the need to give us so many examples, but you know, who am I to turn down a fun example problem? As you write these down, you can very quickly see, oh look, there's the part I want to factor out, right? Last time I showed you the part that we wanted to keep, and now I'm showing you the part that we want to get rid of. Two ways of looking at the problem. So I'm going to pull the x plus y quantity out, and that will leave me with x squared plus 9x plus 20. Notice the way I use parentheses to keep the part that I'm factoring out in a little bundle, and then I use parentheses to keep the part that's left behind, the cute little trinomial, that in a bundle. You have to use both sets of parentheses in order to keep it accurate. I'm not going to get into the theoretical explanation of why. Just trust me, you have to keep parentheses around both chunks in order for it to be correct, okay? Now we're ready to set up our factoring. Two numbers that multiply to 20 and add to 9. Now, I immediately think of all the different pairs of numbers. There's a lot that go to 20. Okay, 1 and 20 or minus 1 and minus 20. Neither of those are going to work. How about 2 and 10? 2 and 10 or minus 2 and minus 10, because they have to add to a positive. They have to multiply to a positive number, okay? And I'm pretty sure it's going to be two positives because this is positive as well. And then the other option is 4 times 5 minus 4 times minus 5. Okay, there we're in luck. It's this one, right? So art project, x plus 4, x plus 5. This quantity just chills on the outside. And that's our final answer. I hope you're starting to kind of feel like, all right, these factoring problems, this whole trinomial factoring thing, multiplies to the last number, adds to the middle number. I hope that's starting to kind of feel like a groove for you. Okay, this one's even more dramatic. Oh gosh, John. This is getting a little squished down here. But what I can see is, okay, there's my x squared. That's what I want. So this must be the part that I don't want. M times the quantity x minus 1. M times the quantity x minus 1. Okay, there's the m, and there's the x minus 1. So I'm going to keep a 7x. Okay, that sounds good. And then down here, I want to take out the m times x minus 1, so that means I'll keep the plus 10, right? The 7 was a plus also. All right, so what I'm pulling out is m times the quantity x minus 1. Now, I don't have to put the m in parentheses because he's on the outside of these parentheses, and he's far away from this trinomial. So he's okay to be out. All right, and what are we left with? X squared plus 7x plus 10. Okay, and we factor, I'm guessing it's the 2 and the 5. That makes sense, right? It's not minus 2 and minus 5 because that would be a minus 7. I'm double checking just to make sure. No, that's right. So I like this one. Okay, so now what I'm telling you is even when you make the list, you can focus in on the ones that you're pretty sure are the right pair. And just write down part of the list if that helps you. Okay, so now this part stays the same. I don't do anything more with that, but I set up my art project and I get x plus 2, x plus 5. Yay. All right. Okay, that's the end of part A, factors that are sums. Let's go to part B. And I'm going to be honest with you. Part B is a lesson that annoys me. We're going to talk about pyramids and cones. It's not hard. John just goes crazy in the book, giving you all kinds of definitions and information that you really don't need often to know. So here's what I'm going to do. I'm going to show it to you. He starts by talking about a pyramid. A pyramid, the thing that's different between a pyramid and a cone is that a pyramid is based on a straight-sided base, right? See how that's, what is that, a pentagon? I don't know how many shaped sides it is, but see how they're straight sides? And a cone is based on, I'll flip and show you. A cone is based on a circle, all right? That's the difference between a pyramid and a cone, all right? Now, pyramids can be on triangles or squares or rectangles or pentagons or any other polygon, straight-sided object, right? And they have kooky names. The vertex is where everything meets. The sides are called lateral faces. The creases, if you will, between the lateral faces are called the lateral edges. The length of one of these triangles is called the slant height. And then the straight down in the middle is called the altitude usually, sometimes the axis. Will you remember all these words? No, you won't. Can you put a sticky note on this page so that when you need to know these numbers, they're right there? Yes, you can. Please do. Please put right now, pause me if you need to, go get a sticky note and mark this page. I'm waiting. Okay, now you're back. And I don't really have to wait. That's the fun of video, right? I can just say, okay, I'll wait, and then I just keep talking. There are also some of the same words over here on the pyramids, and then the same for the cones down here. Now, here's the good news. We're not going to do wonky tipped shapes. We're only going to do straight and relatively perfect shapes. So that makes our lives a lot easier. First, let's talk about volume. Oh, let me just do this. Pyramids have straight sides on their base. They're polygons. And cones, the base is a circle. That's the difference between them. To find the volume of a pyramid or a cone, either way, you take a regular volume formula, right? Area of the base times the height, and you multiply it by 1/3. What that essentially does, let me show you. I'll draw a pyramid because that one's the most fun for me. Let's imagine that is a straight rectangular cylinder, right? The kind we've always had. And we know you would find the area of this base and you'd multiply it by the height to get the volume of the whole thing. Well, when we make a cone, or a pyramid rather, no, a cone, sorry. What we're doing is we're whittling away a whole bunch of this cylinder, right? And mathematically what we're doing is we actually carve away 2/3 of this, and the cone represents 1/3 of that original cylinder. So that's why we multiply it by 1/3, because we're sculpting away, chipping off a bunch of that volume to get down to just the cone that's in the middle. So the 1/3 is the mathematically precise amount. So these are pretty easy to figure out. Find the volume. This is example 72.4. Find the volume of the right rectangular pyramid. And I'm going to show you. This is the picture that we're looking at. So we can see it's built on a rectangle. I'm going to try drawing this in just a minute. It's built on a rectangle, then each of the sides comes up to a point. And then we know the dimension there, and then this arrow is going to the height that's inside of it. I'll make that a little clearer when I draw it. It's kind of dark for you to see right now. Okay, so this is my drawing of the pyramid. There's the rectangle on the base. This is 9 inches. This is 7 inches. Then there's a point up here-ish, and each one of the corners comes up to that point. Pretend it's perfect, okay? Then from the top, there's a line that drops down right to the middle of the base, and it meets it at a right angle. This is what we call the altitude, or you can also think of it as the height, right? Either way. So now, using our formula, it's going to be 1/3 times, what's the area of the base? 9 times 7, times the height, which is, I didn't write down the number, 8 inches. Okay? And so there we have it. 1/3 times the area of the base, which is length times width, 9 times 7, times the height, which is 8. That's the height, and that's 8 inches. John gave us all 3 of these numbers. We did not figure those out. Okay? So now I'm going to simplify before I multiply. I don't want to multiply all this together and then divide by 3. This technically is all over 1, right? Because it's not a fraction. So I'm going to do the 9 against the 3. That'll give me another 3. 3 times 7 is 21. 21 times 8 I can do in my head. 8 times 2 is 160, plus one more 8 is 168 inches cubed, because it is a volume, and that's the right answer. Yay! All right. Now let's do the volume of a cone. And let me just remind you, this was the volume of a pyramid. Sorry. I can do math all day, but my ability to talk fades quickly. This is a pyramid because it's based on a straight-sided shape. It's based on a rectangle, right? That's how we know it's a pyramid. This one is based on a circle. So we know it is a cone. Both of them involve carving away 2/3 and keeping 1/3 left. So that's why the formula works for either one. And this one's got little dotty dotty dot inside the middle like that. Pretend it's perfect. It is not. It says 6 feet like that. And then it says 8 feet. So this tells us that the radius is 6 feet and 8 feet is the height. Okay, cool. So now we're gonna set up our calculation again. It's gonna be 1/3 times the area of the base. Okay, the base is a circle. The area of a circle is pi r squared. So that means it's going to be, we can write it right in here, it's going to be 3.14 times the radius squared. So we can just write it like that, we don't have to square it yet, times the height. Okay? This is one way to work these problems, is to put all the numbers in the calculation in place before you start multiplying anything. Oftentimes what I like to do is I like to find the area of the base first and then multiply it by the height. But this time I'm choosing to do it work the problem the other way, where I show you all the pieces of the calculation in one place. This is usually the way John shows it in the solutions manual. One's not better or worse. I like to show you options so you can choose the style that works best for you. Either way would work for me. All right, what I'm gonna do though is I'm going to square this. That'll make it 36. Now I can cancel. I wouldn't cancel the 3 against that 6 because that 6 needs to be squared. That would be a mistake. But now that I've squared the 6 and gotten 36, now I can cancel against here and I will get 12. So now I need to multiply 12 times 8 times 3.14. So I'm going to do that like this. I'm going to put the 3.14 on top. 12 times 8, I happen to know is 96. It's 80 plus 16. So I'll put the 96 there, and now I'm going to multiply. That's my product, 301.44 feet, and this is volume, so it's cubed, and that's the correct answer. Make sense? So all we're doing is taking our regular volume equation and we're multiplying it 1/3. Okay, that's for volume, filling up the shape. Now we have to deal with surface area. And surface area is not the same for pyramids as it is for cones. Annoying. This is a really long lesson. I hope you're still buckled in. Let me plug in my phone. I'd hate to have my phone die in the middle of all this. Wouldn't that be sad? It has happened before. And when it happens, I just send you 2 pieces. Hang on, I'm gonna move my camera. Whoa, are you dizzy? Okay. You're back in frame. I'm back in frame. To make it so my extension cord doesn't pull the phone off the filming apparatus. It's on a chair. Okay. Surface area of pyramids. All right. Find the surface area of this regular square pyramid. Okay, so it's based on a square. Pretend it's perfect. Okay. Dimensions are in centimeters. Okay. Oh, I'm sorry, this is a 6, not a 5. All right, so what we have to do is we have to consider that there are 4 equal triangles, one coming up from each side of the square. We know that the square has 4 equal sides, so we know that the triangles have 4 equal bases, and we know the heights are the same because it tells us it's a regular pyramid. That means it's perfect. So we don't have to calculate each triangle separately. We know we'll just figure it out and get 4 of them. So now, there's one more number on here that I think is really hard to see, but it looks like this. It goes like this, and then there's a 5 by that, okay? So what that tells us is that each individual triangle on the side has a base of 6 and a height of 5. So the area of a triangle equals base times height divided by 2. So the area of this triangle is going to be base of 6, height of 5 divided by 2. But we also need 4 of them. So I'm going to multiply it by 4 at the same time. All right? Now, this is going to cancel, and I get a 2 here. 6 times 5 is 30. 30 times 2 means that all 4 triangles add up to 60 units, whatever that is. We haven't gotten there yet, okay? The only other part we need to get the surface area is the base. And that is the square, and that is going to be 6 squared, right? Because 6, 6, 6, 6. So that equals 36. And that gives us a total surface area of 96, let me look, what's my unit? Centimeters. Squared. Surface area is an area measure, and so it's squared, not cubed. Volume is cubed. All right, and that's correct. Okay, so here we have to take it apart and look at each of those triangles. They're all the same, but that's cool. All right, and one more problem. This, by the way, was 72.6. And here comes the last one. And in this one, we're finding the surface area of a cone. Now, this is a little bit different. The lateral, and this dimension here is called also the slant height. And we use an L. I use a cursive L. John used kind of like an italicized L to measure that. And we need another part of the formula here. The lateral surface area of a cone is pi times the radius times the slant height. Oh wait, puffy cloud. I was going to put a square around it. All right, there's the slant height right here. That's where we get the L. Pi, we always know, radius is like so. So on this one, our slant height is 10. And our radius is 8. Doesn't look like it in the picture, but pretend. Okay, so to find the lateral surface area, I'm just going to call that the sides. That will be equal to pi times the radius times the slant height. Pi is 3.14, whoops, times 8 times the slant height, which is 10. All right, that's going to be 3.14 times 80. I'll do that over here. There's our 0. 2 decimal places. So it's 251.2. That's for the dunce hat, if you will. It's for the rounded part. We still have to find the area of the base. That is a circle, so it's going to be pi r squared, so it's going to be 3.14 times 64. Okay, so we'll do that over here. 3.14 times 64. Six, 9, 0, 6, 2. Double checking to make sure I got it right. Pi times 8 squared plus pi times 80. If I did my math right, these should add up, but they don't look right. Did I do something wrong in the adding? (24 to 8). Oh, yeah, there it is. 6 times 3 is 18. So this adds to here, just a second. I'm going to multiply this again because I made a mess of it. 3.14 times 64. Ready? This is where my mistake lay. This I know is 1, 2, 5, 6. Then we put in a 0. We go 24, 8, and then 18. We add it, 6, 9, 0, 0, 2. Okay, that's what I had. So now I'm adding these two pieces together. Oh, this is supposed to be a 6. That's the right answer. Okay, 452.16. My unit is meters, and it's surface area, so it's squared. Okay, sorry I got crazy on my multiplication here. That was my only mistake. These are the formulas you need. This is how you calculate the surface area of the side. It's really just one side. I wrote plural, but it's really just one curving dog collar, don't lick, dunce hat, upside down ice cream cone. And then this is the base, which is a circle. So we use that formula. Pi r squared, right? Okay. We're not going to take this a lot farther. We're not going to take it farther at all. These problems will get thrown in from time to time, but we're not going to really build on this. That's part of the reason why it annoys me, is because it's a lot of fuss and bother for not much future potential. So thankfully you don't have to talk about slant heights forever. I'm so glad this lesson's done. Goodbye.